So let's look at some examples of machines used in sim applications. Safety is super critical when using this milling machine. One, because it's $25,000, and two, because it could cut your arm off. So before working on this machine, safety guidelines have to be followed. You got to make sure that you know how to do it. Read instruction manuals, observe safety rules, dress for safety in the lab. So dressing for safety really means making sure that you don't have any danglies like headphones or things on when you're around the milling machine. That hair is tied back. You don't have any loose clothing around it, so nothing gets caught in there, because it ain't going to stop that machine from running. If something gets caught in there, it might just grind your face up. So that will be something that's really, really important, that before you run it, you really feel comfortable with all the safety rules for the milling machine. So looking at some elements of machinery, equipment used in sim and automation. Again, sim is computer integrated manufacturing. That is the name of our class. So CNC is computer numerical control. And computer numerical controlled robots, transfer systems, feedback systems, things that get response and then adjust what they're doing in response to it. That's feedback. All of these are used to reduce manufacturing costs. So that's one element. Increase product quality and consistency. Enhance manufacturing flexibility. Improve marketability of products. Decrease time to market. And then 6, reduce the reaction time to change in market demands. So you might want to go back through those and make sure you get those 6 things noted, because those are pretty significant for why machinery and equipment used in sim and automation, or the effect that they have in manufacturing. So some common examples of CNC machines used. Mills, we have a milling machine. There's also lathes, CNC lathes, machining centers. Plasma tables would be really sweet. Water jet cutters, you saw a video of that before. Wire EDMs, laser cutting and engravers, that's what we are looking at getting, or maybe already have now, and we do have some rapid prototypers. So these all use computer numerical control, and they all use G&M code, which you're going to learn how to code yourself in the next lesson. So computer numerical control machining and processing, they use computer numerical control, so it's just a system of numbers and letters that cause it to perform functions. And they can perform some things like joining parts together, that would be like additive process, like the rapid prototyper, or separating, which is the milling machine, casting and molding, or forming things, finishing products. They are very productive and cost effective, just because they're so accurate and so quick. So here's some of our computer numerical control tools. A center cutting end mill, a ball end mill, you can see it's rounded on the top, and a non-center cutting end mill. The difference here is it has a hole in the middle of it. We do not have a shell mill. So these 3, along with engraving tools, which is the first thing that you're going to use for your yo-yo, are really the most significant, and we'll get into that in the next lesson. So some examples of robotics used in computer integrated manufacturing applications. If you're welding or joining things, you might have a machine do it just because of the heat used or the precision that you may need to use on it. They can do arc welding, they can do a tungsten inert gas or metal inert gas welding, spot welding, resistance welding, laser welding, plasma cutting. All these hot tasks where there might be risk of human injury are great applications for robotics, which is really kind of a good thing to note, because I believe that was a question that was on one of the finals in the past was, how are robotics best used? And really in any situations where humans can be injured. So that's kind of a significant piece. Sort of obvious, but other examples use material handling, if you need things assembled, loaded, dispensed, packaged, transferred, painted, finishing, or even inspecting. And there are some robots that are used in a company called Multisource in Eastern Lafayette, that they use robots to that have little sensors on them, and they come in and they barely touch the outside edge of the box or the crate or the tool. They actually use medical tools. They make those. They barely touch the outside edge, and that gives them the actual dimensions of the box to make sure that it was machined incredibly precise. So that's how it can be used for inspecting. So here's some examples of transfer systems used in computer integrated manufacturing applications. The automated guided vehicle, and there's not really an example of that in these pictures. The automated storage and retrieval system, which really is not an example of in any one of these either. And then conveyor systems. So these are some conveyor systems. You also have part feeders and just some robotic arms in here as it's sliding down this conveyor. This conveyor system is a very small loop. So maybe parts are put onto here, they're inspected, and then they're taken off and packaged. So some different inspection or feedback systems used. You might have network computers or monitoring software. I gave you the example of the sensors that some robots had. Vision systems, as things maybe are using light sensors or types of sonar sensors to detect for imperfections, and they actually do have actual vision systems that can do visual inspections. Laser scans, radio frequency identification systems, RFID, and that's pretty much it. Always love you.